where they will give you velocity of sound as 340 meters per second, 350 meters per second, sometimes even 360 meters per second. Even in Doppler effect they will do that, right? So that is at room temperature. So that was the first factor. The second factor was humidity. If in the surrounding medium, water vapor increases, water vapor is lighter than air, that means the density decreases. That means the density decreases, and we know that V equal to root of gamma P by rho. So if density decreases, velocity of sound increases. So as humidity increases, density decreases, that's why velocity of sound increases. Thereafter, a little confusing question comes. So what happens if pressure increases? So sometimes students go with this formula, saying that, sir, velocity is directly proportional to root of pressure. My dear, you can say velocity is directly proportional to root of pressure provided gamma and rho both are constants, but rho is not constant. That means your assumption is wrong. That means you should go with this formula, which is independent of pressure. So velocity of sound is independent of pressure, and therefore there is no effect of pressure. So if you go to high mountains or if you go deep into the mines where there are pressure changes, the answer is velocity of sound does not change. This is where we stopped last time, right? I told you Sabai's formula is not there, right? Now we are continuing. Wave motion में भी मैंने काफी कुछ introduce कर दिया था. Wave motion में काफी कुछ introduce कर दिया था. What was that? We derived equation of a simple harmonic progressive wave. What was it? Y is equal to A sin omega t plus alpha. This is the equation of simple harmonic progressive wave. After that we said that A, this is y-axis which talks about the displacement of the particle, and if this is the movement, right, this is direction of propagation of wave, and if the wave is advancing along positive x direction, right, as it advances along positive x direction, this alpha, which is initial phase or epoch, is given by minus 2 pi x by lambda. Why was this minus sign coming? I explained it to you. Was it phase lag? Yes or no? And therefore my equation becomes y is equal to a sin 2 pi, right? Bolo. Check करो please. क्या हुआ? अभी तो सब बंद होगा. स्टोरेज है ना पक्का? सॉरी. स्टोरेज है ना पक्का? किसने देखा? 12 वापस करना पड़ेगा. एक मिनट रिकॉर्डिंग नहीं चालू था. रिकॉर्डिंग चालू ही है. 5 मिनट तक हो, उसके बाद बंद ही हो गया अपने आप एग्जैक्ट 5 पे. निकाल दे फोन निकाल. तो 200 MB में पहले से चालू है. मतलब अगर चलो सेट ऑन पास, मतलब अगर मैं बोलूँ 145 ऑनवर्ड्स मुझे रिकॉर्डिंग चाहिए, तो मुझे जरा वो इस पे लिख के दे देना. पेन ड्राइव भी कर रहा है. कौन सा है फोन? मतलब कितना जी? 13 14. नहीं मेमोरी कितना है? एकदम पक्का. अरे मेमोरी तो इसमें भी दिखा रहा है. एसी चालू कर यार, इतना गरम क्यों? मेमोरी चेक करना कितना है. बोर्ड लास्ट में स्टूडेंट बोर्ड दिख रहा है? बोर्ड दिख रहा है? तुझे नहीं दिख रहा है? तो यू गेट योर आईज चेक. पीछे वाले को दिख रहा है? आगे आगे बैठ. आगे बैठ. जल्दी कर जल्दी रोनी. I'm so sorry students. सिनेमैटिक मत करो. वो ये हुआ. अरे तू लगा. अभी रिमोट है ना, गायब कर दो, उधर दे मत उनको, तो बीच बीच में टाइम पास करते रहते हैं। जिनको ठंडी लगता है घर पे बैठो, टाइम पास उधर एकदम एसी के नीचे बैठोगे, बाद में हुडी डाल के बैठेगा। बोल ही नहीं सकते, बजाऊंगा तो। एक मिनट, क्रॉस ऑफ फिंगर। Good afternoon, students. Work Power Energy lecture number 2. अच्छा मैंने ये किया इसके लिए, मार पे लगना अभी ये कोई किसका है? वो पक्का वायरल कर सकता है, वो मेरे पे खुन्नस की है, और 12th स्टैंडर्ड पास हुआ, मेरा सुपारी भी ले सकता है। मेरे विल में लिखा है, मेरे फैमिली मेंबर्स को मेरा मर्डर हो गया तो आजन तिवारी को इसी में आ रहा है ना, डोंट यू डेयर टू डू दैट। सीधा पुलिस स्टेशन में तेरा ही नाम जाने वाला है। पुलिस पूछेगी ना किस पे डाउट है, एकमात्र बंदा है अर्थ पे जो मर्डर कर। नहीं वैसे हो सकते हैं ज्यादा लोग, खुन्नस हो सकता है मेरे लिए बहुत सारे लोगों को। तो राठी को तो हर 2 स्टेप्स के बाद उसका एनीमे मिलेगा, हर 2 स्टेप ना अगला वाला। उल्टा ये वीडियो वायरल हुआ ना तो हम लोग नीचे डिस्क्रिप्शन में डालेंगे कि who the hell says that the students are scared of physics. Look at this is physics. अगले वे में प्रोजेक्ट करके बताएंगे, ऐसा पॉजिटिव वे में डालेंगे। It depends on the perception, how do you look at it. Good afternoon, students. This is Waves lecture number 2, synopsis. In the previous class, we talked about sound waves, right? And partially wave motion and Doppler effect. Today, we are doing the remaining part, that is wave motion and Doppler effect are remaining part, and stationary waves. Last time I told you that I just try to arrange the tuning forks and will show you how the frequencies are marked. I also told you that the frequencies which are marked on the tuning fork, they are the global frequencies which are used at all the levels all over the world in designing any musical instrument. It is very effectively used in speech therapy. It is very nicely used in paramedical sciences. For example, if you have got a problem of hearing or something, and when you go to the ENT surgeon, right, that time they will just be in one soundproof room and they'll be having some tuning forks like this. Now over here, if you see carefully, there are some frequencies written over here. Okay, this is written as 256 and it is written over there C. Later if you want to have a look at this, I am having this tuning forks with me for a day, right? I have to return them maybe tomorrow. Now if you see this tuning fork, this is smaller in size, that means the prong size is less. So over here, when the mass is less, that means the frequency of vibration will be more. This is a rubber pad, and when I vibrate, when I just hammer this tuning fork, prongs of the tuning fork, you can literally feel that frequency. Catch it. Yes or no? Yes or no? So when the ENT specialist is checking whether you've got a problem with your eardrum or you've got a problem with your auditory nerve, right? They will put this tuning fork here, here, here. Accordingly, they'll check your auditory nerve. And from outside, they will hammer different tuning forks. And they will check up to what frequencies you can hear, and they will keep asking you. You have to give signals from inside. Doctor will ask you, can you hear? Yes. Can you hear? Yes. Then you will have to say no. तो डॉक्टर को समझ में आता है कि आपको कितना डेफनेस है, कितना पार्शियल लेवल पे डेफनेस है. If it is a problem of eardrum, then accordingly the operation has to be done. And if it is a problem with the nerve, then accordingly the operation has to be done. Right? And that's the reason doctors keep advising that you should not use mobile phone continuously like this, because those radiations of which are coming out, prolonged exposure of any kind of radiation is harmful for human body. They may be mild radiations, but they are harmful. So this is the set of tuning forks. So over here, there are standard frequencies as I told you yesterday, I mean in the previous class: 256 Hz, 288 Hz, 320 Hz, 341 Hz, 384 Hz, 420 Hz, 480 Hz, and finally 512. This was the Indian model, sa re ga ma pa dha ni sa. And I told you that if one sa is frequency 256, then another sa is 512. Apply common sense. These are known as prongs. These are known as prongs, and this is known as stem. Right? So when you hammer the prongs of the tuning fork on a rubber pad, right, then this is counted as the line of vibration. In the sense, when I show you the vibrations, this is the tuning fork at rest. Okay. Now when it is hammered, the prongs go out, the prongs come back to normal, the prongs go in, the prongs go back to normal, and then again prongs go out. Okay. So this is counted as half vibration, and this is counted as another half. In the sense, when prongs go out and prongs go in, this is counted as one complete vibration, because outwards and inwards, both things are taken into account, and the prongs vibrate this way. Correct? So this is the line of vibration, and the prongs vibrate this way. That means the prongs perform transverse vibrations. Because what is the meaning of transverse vibrations? The particles of the medium vibrate at right angles. So when I start with Mendy's experiment today itself, we are going to talk about that. Anyways, the quick summary of sound waves was: velocity is root of E by rho. Velocity of a longitudinal wave is given by V is equal to root of E by rho. When you talk about velocity of sound in air, this elastic constant is three types: Young's modulus, bulk modulus, modulus of rigidity. Right? Air is a gaseous medium, so Young's modulus is not possible. Modulus of rigidity also is not possible, because this is related to length, this is related to shape. That means only this modulus is possible. Right? So when Newton suggested this formula, he took this as K by rho, under root, and he took this as Ki by rho, to be more precise. And therefore he gave it as pressure upon density. And his answer was 280 meters per second, which obviously was well away from the practical answer. The same formula was suggested by Laplace, saying that no, this is not Ki by rho, this is Ka by rho, and therefore this is under root gamma p by rho, and this answer was almost 332 meters per second. So Laplace's formula is correct. Thereafter, effect of different parameters. Effect of different parameters like temperature, what is the effect of temperature? Like humidity, what is the effect of humidity? And like pressure, what is the effect of pressure? Right? Obviously, velocity is directly proportional to root of temperature. Right? For every degree rise in temperature, velocity of sound increases by 0.6 meters per second. Right? As humidity increases, that means amount of water vapor is increasing, that means density is decreasing, and therefore velocity is increasing. So again, it is favored by that. If temperature is increasing, velocity is increasing. If humidity is increasing, then also velocity is increasing, and there is no effect of pressure. Right? After that, we started with simple harmonic progressive wave. So how to switch over from SHN to SHP? If this is y-axis, that means this is the line about which these particles vibrate. That means the displacement is measured with respect to this. So if I give you this particle, then distance of this particle is this, that is x, and the displacement of the particle is this, that is y. Right? So this y and this x, they are different, mind you. Right? Y is the displacement of the particle, and x is the distance of the particle. So if you have got two different particles, their displacements may be same, but their distances can never be the same. If I am taking one particle here, that means on a falling crest, and if I am taking another particle exactly at the same location on previous falling crest or the next falling crest, can I see ये सबका y value same है, लेकिन इसका x value कभी भी same नहीं हो सकता, yes or no? Thereafter we said that this alpha, which is initial phase, is calculated as minus 2 pi x by lambda. मैंने आपको फेज डिफरेंस के दो फॉर्मूले दिए थे. एक फॉर्मूला था 2 pi x by lambda और दूसरा फॉर्मूला था 2 pi upon बड़ा t times छोटा t. So 2 pi by lambda was known as k,
right? Propagation constant, and 2 pi by t is known as omega.
Yes or no? And that's why we said that wave motion is doubly periodic.
So what was our very first answer? Y is equal to a sin omega t minus 2 pi x by lambda. This is equation of a simple harmonic progressive wave. Second style of writing this was a sin 2 pi by bada T into chota t minus 2 pi by lambda into x. Right? Thereafter we can take 2 pi out to make it a standard equation. So 2 pi out, small t upon big T minus x upon lambda. Thereafter y is equal to a sin 2 pi frequency times t minus x by lambda. Thereafter y is equal to a sin 2 pi by lambda.
अब ये lambda common कर लेने के लिए I should multiply and divide by lambda here.
So f lambda will give me velocity and this lambda goes out.
So this is
Vt minus x. Vt minus x. And finally this is a sin 2 pi by lambda can be written as k times Vt minus x. I told you very clearly, students. I told you very clearly. When you see the minus sign inside the bracket, when you see minus sign inside the bracket, that means the wave is propagating along. The wave is propagating along positive x. Propagating along positive x.
but when you see minus sign एकदम out, एकदम amplitude के just पहले,
that means the wave is not this way, but the wave is this way. Are you getting this? अगर इसके आगे minus sign आया, मतलब you are talking about कि you started from zero, but in place of getting crest first, you are getting trough first. That is the meaning of that.
so don't get confused for this minus sign and this minus sign. अगर बेटा ये इक्वेशन मैंने ऐसा लिखा है
माइनस प्लस, इसका मतलब ये वेव का डायग्राम ऐसा होना चाहिए. सोचो, ये वेव का डायग्राम ऐसा होना चाहिए. सोचो,
मुझे माइनस पहले मिला और इसके अंदर प्लस साइन है. दैट मींस दिस टाइम इट इज नॉट फेस लेग, it is phase lead. That means the wave is traveling along
negative x direction. Yes or no? Okay, so this is where we stopped last time. Now, in a synchronized way, we are going to study superposition, and I am going to club 3 chapters together. When 2 SHMs combine together, what happens? When 2 SHPs combine together, what happens? And how do you get stationary waves? That means we are going to understand 3 things together. How do you get stationary waves? How do you get a beat wave? And what is the meaning of principle of superposition for 2 SHMs? SHMs first. X is equal to a sin omega t plus alpha. X is equal to a sin omega t plus alpha. SHM number 1, SHM number 2, amplitude 1, amplitude 2, omega t1, omega t2, alpha 1, alpha 2. That means you are studying this at the same time. So what are the things which are not the same? The things which are not same are amplitude and alpha, and therefore displacements. So when I go for principle of superposition, will I get x is equal to x1 plus x2? And we stated that x का आंसर अपना आया था r टाइम्स साइन ऑफ ओमेगा t प्लस अल्फा. ये थोड़ा मैंने अलग फॉन्ट्स में लिखा है. इसका मतलब क्या होता है कि r इज द रिजल्टेंट एम्पलीट्यूड एंड अल्फा इज द रिजल्टेंट एपोक. जब मैंने शुरू किया था ये 2 SHMs के एम्पलीट्यूड्स अलग अलग थे. जब मैंने शुरू किया था इनके एपोक्स भी अलग अलग थे. तो मेरा फाइनल आंसर, this is SHM number 1 and this is SHM number 2. We proved that combination of 2 SHMs is SHM. That means this is resultant SHM. That means this is resultant SHM. And therefore we should talk about R. What is the meaning of R? R is the resultant amplitude, and the resultant amplitude is given by root of A1 square plus A2 square plus 2 A1 A2 cos of alpha 1 minus alpha 2. Yes or no? Mind you, when I started, I had A1, A2 and I had alpha 1, alpha 2. When I started, I had A1, A2 and I had alpha 1, alpha 2. That means my final answer should have all 4 of them, because that is the data I have, right? Likewise, what will be alpha? Alpha is the resultant epoch, and was it tan inverse of A1 sin alpha 1 plus A2 sin alpha 2 upon A1 cos alpha 1 plus A2 cos alpha 2. Again observe, are you getting the same four things? That means in this equation also you have got A1, A2 and alpha 1, alpha 2. So this is what we studied in SHX. Now how is it linked with SHPs? ध्यान से देखो, मैं एक दो इक्वेशन ले रहा हूँ. अभी x की जगह पे डिस्प्लेसमेंट हम लोगों ने y बोला है, इधर हम लोगों ने डिस्प्लेसमेंट x बोला था. इधर y इसलिए बोला बिकॉज x का मीनिंग और कुछ है. इधर y इसलिए बोला क्योंकि x का मीनिंग और कुछ है. x इज द डिस्टेंस ऑफ द वाइब्रेटिंग पार्टिकल फ्रॉम ओरिजिन. x is the distance of vibrating particle from origin and y is the displacement of that particle. तो अभी डिस्प्लेसमेंट के लिए मैं या y यूज कर रहा हूं क्योंकि x किसी और के लिए रिजर्व्ड है, राइट. y1 is equal to a sin omega 1 t plus 0 and y2 is a sin omega 2 t plus 0. ध्यान से देखो, अब इसमें क्या सेम है, इसमें क्या सेम नहीं है. इधर एम्पलीट्यूड सेम नहीं था, एम्पलीट्यूड सेम नहीं था, अल्फाज सेम नहीं था, फ्रीक्वेंसीज सेम था, ओमेगा ओमेगा फ्रीक्वेंसी सेम था. इधर सब कुछ उल्टा है. इधर एम्पलीट्यूड सेम है, चेक करो, अल्फाज सेम है और जीरो है, एंड ओमेगाज सेम नहीं है. इसका मतलब फ्रीक्वेंसी सेम नहीं है, इसका मतलब इनके पीरियड्स सेम नहीं है. यस और नो? मतलब इसका बिल्कुल उल्टा, राइट. पैटर्न वाइज ये पैटर्न कैसा दिखेगा? व्हेन आई एक्चुअली ट्राई टू ड्रॉ दिस पैटर्न, द पैटर्न वुड लुक समवॉट लाइक दिस. व्हेन टू waves of same amplitude and same epochs but different frequencies superpose with each other. एक वेव ऐसा गया, एक वेव ऐसा गया, ओके, और इसका टाइम पीरियड है, इसका टाइम पीरियड है से t, इसका टाइम पीरियड है से t. लेट अस कॉल दिस इज t1, राइट. ऑब्वियसली उनका फ्रीक्वेंसी सेम नहीं है, मतलब टाइम पीरियड सेम नहीं है. मतलब दूसरा वेव या तो इससे फास्ट है या तो इससे स्लो है. दूसरा वेव माइंड यू उनका इनिशियल फेज सेम था, मतलब दोनों सेम लोकेशन से शुरू हुए थे, राइट. और ये वेव ऐसा जा रहा है, अभी ये ऐसा जा रहा है, right. Observe this carefully. Crest of one is meeting with crest of other. यहां पे जाके crest of one is meeting with trough of other. यहां पे आके trough of one is meeting with trough of other. आगे कहीं पे जाके ये crest और trough था ना, तो यहां पे trough और crest मिलेगा, right. इसका मतलब the pattern is this way: crest, 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 trough, 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 crest, repetition. इसका मतलब they favor, they oppose, they favor again, they oppose, they favor again, and so on. So at this point, if I try to find out the intensity, can we say the amplitude will be doubled because it is a plus a, yes. But the intensity will be 4 times. फिर यहाँ पे आके क्या होगा बेटा? Exactly यहाँ पे आके क्या होगा? इसका भी एम्पलीट्यूड है, इसका भी एम्पलीट्यूड है, लेकिन इसके क्रेस्ट के सामने इसका ट्रफ आ रहा है. इसका मतलब दे विल नलिफाई ईच अदर. तो इधर रिजल्टेंट एम्पलीट्यूड क्या हुआ? 2a. इधर रिजल्टेंट एम्पलीट्यूड क्या हुआ? 0. इधर क्या हुआ? -2a. फिर इधर क्या होने वाला है? 0. फिर वापस +2a. पैटर्न विल रिपीट. So if I try to understand this wave graphically and practically, then mind you, the wave would be somewhat like this. इसका एम्पलीट्यूड a है, इसका एम्पलीट्यूड a है और इसका एम्पलीट्यूड ट्वाइस है. That means if this is the amplitude का line and if this is the amplitude का line, that means this amplitude का line will be doubled. Amplitude का line will be doubled. मुझे यहाँ पे r क्या मिला? +-2a. यहाँ पे 0, फिर वापस +-2a, फिर यहाँ पे 0. इसका मतलब पैटर्न ऐसा कुछ मिलेगा मुझे. पैटर्न मुझे ऐसा कुछ मिलेगा. And the wave will go this way. And the wave will go this way. This is called beat wave. This is called beat wave. The points of highest amplitude are known as waxings, and the points of zero amplitude or lowest amplitude are known as wanings. अब प्रैक्टिकल लाइफ में ये कैसे साउंड होगा, दैट इज वेरी इंपॉर्टेंट। आई एम स्पीकिंग अ सेंटेंस, टू एवरी एक्शन देयर इज एन इक्वल एंड ऑपोजिट रिएक्शन, दिस इज न्यूटन्स थर्ड लॉ ऑफ मोशन, राइट। अब ये सेम सेंटेंस दूसरा कोई स्टूडेंट बोलता है, एम्पलीट्यूड सेम रखा है उसने, लाउडनेस सेम रखा है, मेरे से ज्यादा लाउडनेस भी नहीं, मेरे से कम लाउडनेस भी नहीं, लेकिन वो स्टूडेंट ये सेंटेंस ऐसे बोलता है, टू एवरी एक्शन देयर इज इक्वल एंड ऑपोजिट रिएक्शन। मतलब मेरे और ये स्टूडेंट के बोलने में क्या फर्क था, टाइम। वो स्टूडेंट स्लोली बोल रहा था, राइट, दैट मीन्स माई टाइम पीरियड एंड दैट टाइम पीरियड इज नॉट मैचिंग, राइट। सो T1 is not equal to T2. Here the condition is T1 is not equal to T2, right? So when I try to understand the final wave, अभी मैंने और वो स्टूडेंट ने साथ में बोला और हम लोगों ने कंप्यूटर में ये दोनों वेव सुपरपोज करके दी कि अभी मुझे फाइनल पैटर्न क्या दिखेगा। Then if I try to understand this sound wave wise, it would sound like this. To every action there is an opposite reaction. This is third law of motion. मतलब loudness zero, loudness zero, loudness zero. If I try to understand this light wave wise, lot of brightness, then it will become dull, 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 zero, again brightness and so on. Dark fringes में और bright fringes में ऐसा नहीं होता था बेटा, क्योंकि वहां पे आप coherent sources use करते थे। Either they completely favor each other or they completely opposite. Yes, yes, या तो no, no, या तो yes, no, या तो no, yes, उसके बीच का कोई आंसर ही नहीं आता था उसमें। तो उसमें dark fringes, bright fringes, dark fringes, bright fringes. Are you getting this? अभी इसमें क्या मैच नहीं हो रहा था, फ्रीक्वेंसीज मैच नहीं हो रहा था, राइट। व्हेन यू टॉक अबाउट रिजल्टेंट वेव नाउ, देन दिस y इज गिवन बाय y इज इक्वल टू r sin 2 pi ft। रिजल्टेंट इक्वेशन ध्यान से देखो, डज इट लुक लाइक स्टैंडर्ड इक्वेशन ओनली? आपका पहला इक्वेशन क्या है, a sin 2 pi ft। आपका दूसरा इक्वेशन क्या है, a sin 2 pi ft, लेकिन इसमें f1 आएगा, इसमें f2 आएगा, इसमें रिजल्टेंट f आया। और ये जो r है ना, when you go for the rule sin of c plus sin of d, ये r का मतलब होता है 2a cos of pi f1 minus f2t। तो इसमें जो वेरिएबल फंक्शन है ना, वेरिएबल ये वाला जो टाइम के साथ चेंज होते रहता है, मैं जब बोल रहा था आप लोगों को जैसे जैसे टाइम जा रहा है आपको फीलिंग डिफरेंट आ रही है ना। मैंने 5 सेकंड के लिए एक सेंटेंस बोला, लेकिन मैंने कैसे बोला, अनलेस एंड इरेक्टेड अपॉन बाय 5 सेकंड्स ओवर, राइट। तो ये 5 सेकंड में आपको जो वेरिएशन फील हुआ, दैट वेरिएशन इज बिकॉज ऑफ डिफरेंट फ्रीक्वेंसीज एंड दिस डिफरेंस इज कॉल्ड बिट फ्रीक्वेंसी। दिस डिफरेंस इज कॉल्ड बिट फ्रीक्वेंसी। सो व्हाट इज बिट फ्रीक्वेंसी स्टूडेंट्स? Bit frequency is nothing but delta f and it is f1 difference f2, f1 difference f2. Now very important, suppose I take 2 tuning forks suppose I am taking 2 tuning forks, एक के ऊपर फ्रीक्वेंसी लिखा हुआ है 256, चेक करो, और एक के ऊपर फ्रीक्वेंसी लिखा हुआ है 341, देखो इधर लिखा है 341f। अब इसका फ्रीक्वेंसी है 256 और इसका फ्रीक्वेंसी है 256 and this is 341. That means the frequency difference is very large, right? The frequency difference is 85 hertz. So when I hammer both of them on a rubber pad, when I hammer both of them on, एकदम हाथ पकड़ना, बोला था, right? और ये दोनों साउंड वेव सपोज मैंने साथ में सुपरपोज किया, तो पता चला बीट्स तो फॉर्म होगा, बट ह्यूमन ब्रेन को समझ में नहीं आएगा। When there are 2 different frequencies sounded together, bits will be formed, but human brain will not understand this. Reason: if delta f is f1 minus f2, is it 1 upon delta t? So what is delta t? Is it 1 upon f1 minus f2 का reciprocal? Now this delta t, according to persistence of sound, human brain has capacity to understand this for 0.1 second. 2 ट्यूनिंग फॉर्क का फ्रीक्वेंसी का डिफरेंस सपोज 10 से ज्यादा है, राइट, 10 से ज्यादा, इसका मतलब टाइम डिफरेंस 0.1 से कम है, मतलब वो फॉर्म तो हुआ होगा, बट माय ब्रेन कैपेसिटी इज नॉट सच कि आई कैन अंडरस्टैंड दिस। व्हाटएवर यू सी द इफेक्ट ऑफ दैट रिमेन्स ऑन योर ब्रेन फॉर 1/10 of a second. Likewise, whatever you hear, the effect of that remains on your brain for 1/10 of a second. So when I take one tuning fork of frequency say 420, another tuning fork of frequency 480, that means difference 60 हो गया, right? So time is 1 upon 60. This is 6 times faster than what my brain understands. This is 6 times faster than what my brain understands. Is it stop?
लो बैटरी, कोई बात नहीं, फिर इससे मैं रिकॉर्डिंग ले लूँ, कोई बात नहीं, हटा दीजिए, फिर मैं यहाँ से means the bits will be formed but the bits won't be understood by human brain, right? तो ये आर्टिकल और ये आर्टिकल में फर्क समझा, इसमें जो सेम था इसमें सेम नहीं था, और इसमें जो सेम नहीं था इसमें सेम था. Simultaneously how to understand stationary waves. Check please. y1 is equal to a sin 2 pi small t upon big T minus x upon lambda, and y2 is equal to a sin 2 pi t by t plus x upon lambda. सब कुछ